Hi everyone, Jason here with another Makera CAM example project, and in this one we're looking at how to machine a multi-part wooden phone stand through one of our Easter themed and spring projects. First, you can grab any of the files you need for this project from the knowledge sharing page on our wiki site. If you scroll on down, you'll see that we include all the files from all of our examples that we show. So for the Spring 2025 example projects, you can choose to download the Rabbit Phone Holder DXF file that we'll be using in this tutorial, or instead you can choose to download the completed Rabbit Phone Holder MKC for a full Makera CAM file, which we'll be creating throughout this tutorial as well. Once you've launched Makera CAM, we can create a new 3-axis project, and the first thing we want to do is set up our stock to match the stock that we'll be using accordingly. I'll be using a piece of hardwood for this project that is 150 millimeters in length, 150 millimeters in width, and about 20 millimeters in height. So I'm going to set up my stock accordingly, like so. Next, we want to import the design file into this document, which showcases how Makera CAM can work with 2D vector files as well as 3D design files like we show in some of our other tutorials. So I'm going to import that 2D DXF that you can grab from our wiki site, and you can see that it might not first land in the correct spot on your stock here. So after importing your designs, you can easily use the transform tool to move things, and I'm going to use the quick align stock button to center this design on our stock automatically, like so. You can also use the transform tool to rotate, flip, or mirror any designs that you import as well, though that won't be necessary as this fits onto the stock that I'll be using. You do also want to make sure that you have enough room around the stock though, or around your design for any of your clamps and things like that. So keep that in mind on where you might put your clamps as you import your design here. Now, this is going to actually be a two-sided project where we're going to machine the top side and then flip our stock over. And there's a couple different ways you can do this, but one of the best ways to do it is using simple alignment pins. Where we might just insert pins in our design to help flip our stock over. And I don't have any holes in my design to use for alignment, but we can use Makera CAM's Create feature by clicking on our Transform window and then clicking Create to create a simple 2D model. And we can create a simple circle that can be used for our alignment holes. So I'm going to make a circle with a diameter of 3.175 millimeters, or 1/8 of an inch. And I'm going to just simply place that hole somewhere in my stock that isn't too close to my design, like there. Now, we need at least 2 holes for alignment. So I'm going to select this hole, then go to my transform tools and go to mirror. And what I'm going to do is I'm going to mirror the hole, but not along itself. I'm going to mirror it along the stock center, and I'm going to create a copy. So now when I generate this mirror, it mirrors the hole, but it actually mirrored it over the center of my stock in the horizontal direction. So now I have 2 alignment pins that are perfectly aligned horizontally and centered with my stock, which I can use to flip my stock over later during the manufacturing process. Okay, so at this point we have set up our stock, we've imported our design, and we've also created some holes that we'll be using for alignment. Now, let's actually start to prepare the toolpaths for manufacturing. And we typically start with the smallest toolpath to the largest toolpath. So I'm going to select the intricate details of my rabbit here by selecting my rabbit design, like so. And then we're going to use this to create a pocket. So what I'm going to do is create a 2D pocket toolpath. Okay. And the first thing we want to do is set our end depth because we're working with a 2D design. That's something that we can set manually. So I'm going to set my end depth to be 0.5 millimeters to machine this pocket to be about 0.5 millimeter or so. I don't have to change my safe positions or anything like that, but I do want to change my tool. So I'm going to delete the tool that I was using in my last pocket and instead grab a single flute engraving bit. So I'm going to grab a 0.5 millimeter engraving bit for this project, so a slightly larger engraving bit because it's a slightly larger pocket here that we're working with. And notice that my tool properties were set to hardwood automatically based upon the stock parameters that I set earlier. So you might need to, or you might consider adjusting your default parameters, but in general, these default feeds and speeds are a good starting place to work with. One thing that you might want to change is you might want to change your tool number to correspond to either the order that you're using this tool. So for example, I might use this tool first, or the number that this tool is loaded in the Carvera's automatic tool changer if you're using the Carvera for this project. Next, we can look at our path strategy. Offset works really well to clear out a intricate pocket design like this, so I'm going to leave that as offset. And I don't need to use ramping. That's a more gentle way to enter your stock, but with something softer like wood, that's not always necessary. But if you were using an engraving bit with metal, you should absolutely consider using ramping, as we discussed in some of our other tutorials. So I'll calculate this, and you can see we now have our pocket design for our rabbit here. Now, the next thing that we'll do on the top of our stock is we can drill these holes. So I'm going to hold shift and select the 2 holes that we created, and now create a 2D drilling toolpath. So for our end depth, we want to drill not only through our stock, but also through a piece of wasteboard that we'll put below our stock that we can insert our alignment pins into. So I'm not going to drill to a depth of 20, I'll drill to a depth of 25 millimeters, which will be enough to plunge 5 millimeters into whatever wasteboard I put below my stock. For the tool, you would typically select a drill bit, but I don't actually have a drill bit that's long enough to do this. I don't have a 25 millimeter drill bit on hand. So instead, I'm actually going to use a single flute end mill that's, I can use my 25 millimeter or 32 millimeter end mill to do this drilling operation as well. So this is a 3.175 diameter bit, so that'll fit in my 3.175 holes for my 1/8 inch alignment pins just fine. I have hardwood selected as my default cutting parameters. And I can again choose to modify these parameters if I'd like, or change my tool number if needed. Now we do want to enable a retract, so the retract will prevent this tool from just plunging straight down, and instead we'll actually use like a peck drilling operation. So I'm going to choose a relative retract, so it will retract a little bit each pass, and I will keep this to be a relative retract of 1 millimeter. Should work fine for this path strategy, and then I can calculate this toolpath. And then we have one more thing we're going to machine for the top here, and that's going to be this pocket where we clear out the area for the phone to rest in, a nice little pocket here. So let's create another 2D pocket toolpath. And for the end depth of this one, I'll set this to be 6 millimeters, which should be a nice pocket for our phone to rest in. And for our tool, I think I'm going to use the same tool I used earlier for the drilling operation. So I'll select my 3.175 by 25 millimeter end mill. This is much longer than I need, so I could instead choose to use, let's say, a 12 millimeter or even an 8 millimeter end mill instead. But this will prevent me from having to do another tool change, and there also won't be a lot of stress on this bit. So a 25 millimeter end mill would work fine. For a pocket like this, you also might consider using a ball nose bit if you wanted to. That would also work fine. So, there's a range of bits you could choose to do some type of pocket clearing path like this. Then I could again choose to modify the parameters, but I won't change my tool number, so that way it'll be the same tool number assignment as it was in my previous toolpath, so I won't be prompted for a tool change for this one. And for this time, for the path strategy, let's choose parallel. So rather than tracing the perimeter and working around in an offset, parallel will just sweep back and forth, which is a little bit quicker for clearing out a larger area like this. Not as well refined if you're going to do something intricate like we did earlier with the rabbit, but it should work well for this pocket clearing path. And again, I'm not going to enable ramping, as we discussed earlier. It won't be necessary for wood. So I can calculate this. That'll clear out this pocket. And that concludes the toolpaths for the top of the job. We won't cut out this part from the top. We won't do that. We will cut the part out from the bottom. So at this point, I'm actually going to right-click my paths and save these paths and export them as a G-code file for the top as we go here. I'm now going to start working on the bottom, and you could in theory make a new design document, but in Makera CAM, we can also just create a new work coordinate system that works with the bottom. So let's click this plus button here, and let's name this new coordinate system bottom. And then what I want to do is I want to rotate and flip around just like I'm going to flip my stock in the real world. So you'll see that our default origin point is the top left corner of what would be the top of my stock. So now I'm going to rotate this around So I'm looking at the bottom of my stock, and I want to select what would be the top left corner of the bottom of my stock, which would be this corner right here. So that's going to be my new origin point for the bottom work coordinate system. I then press OK, and you'll see that we have a shadow of our toolpaths and our design on the bottom of our stock, which of course is actually the top, but the new relative bottom, if you will. So now what we're going to do is we can re-import those vector designs that we used earlier, and we have to get things kind of aligned here. So using the transform tool, I'm going to click move and do my quick alignment, just like I did before. If you did make any scaling adjustments, you'd have to scale this to be the same as what you did before. And you could, of course, use manual alignment or set manual positions. And then we're going to mirror this across the stock center, but I don't want to make a copy. I just want to mirror this. And that should align my design just fine. And you can see with the shadow of our work coordinate system preview that everything is nice and aligned there. You could also use the center to center tool to align your design features if you couldn't mirror things. That works well, as we show in some of our other videos. But this was a pretty simple alignment and flip. Now, we won't actually need this box because there won't be a slot for the phone on the bottom of the base part here. So I'm going to delete that box. And if you find that the toolpaths are distracting from the first work coordinate system, you could always come over to your first work coordinate system and just hide the different features. So that way from the bottom, you can't see those if you find that to be a little distracting. So first thing we're going to do for the bottom is we can select our rabbit, and we're going to create a 2D pocket, and we'll set this to be the same settings that we use for the rabbit engraving on the top. So that was an end depth of 0.5 millimeters. That was using our 0.5 millimeter engraving bit set to hardwood, and we can make sure that our tool number is assigned to be the same so you wouldn't have to reload it in a different slot of your tool changer. We'll use offset for our strategy, and we don't need ramping, so we can calculate that toolpath. Next, we're going to go ahead and cut out these parts using contour toolpaths. And in theory, you could select the outline of the rabbit and the outline of your base and do one contour toolpath. But I actually want to offset my cut a little bit for the rabbit. So I cut a little bit away from my pocket. And if I selected both the base part and the rabbit part, I'd have to offset them proportionally in the same toolpath, which I don't want to do. So let's create two contour toolpaths here. So I'll first select the outline of my rabbit. This time I didn't select the whole design, just the outline. And let's create a 2D contour toolpath. Now I want to machine a little bit past my stock to make sure I cut all the way through. So instead of machining to an end depth of 20 millimeters, let's go 21 millimeters. And then I need to select a bit that's long enough to do that. So I'll grab the same 3.175 by 25 millimeter end mill with hardwood set that I've used earlier in this tutorial. Again, making sure that my tool number matches. Now, for the strategy, we want to run along the outside. So this will run our bit along the outside of the profile here to make sure that the design is not cut in any way. But this is where I mentioned I want to do an offset. So I don't want to run right along this perimeter. I want to leave myself a bit of a gap. So let's say something like 2 millimeters. We don't need to use ramping, as discussed earlier, but we do want to enable tabs. Tabs will hold the part in place after this contour is cut, because this contour will separate the design part from the rest of the stock, and we don't want that to then project or fly out of the material or anything like that, as that could damage the bit, damage the part, etc. So we can create tabs by clicking custom, and these tabs will remain in place to hold the part in place, and then they can be cut away later. So you can choose a rectangle or triangle shaped tab. I'll choose triangle, and I'm going to set my tab width to be 10 millimeters and my tab height to be 3 millimeters, and then use this add button to click along my perimeter to draw a few tabs. And if you can, put them along the flat spots of your design, as that will make cutting the tabs away easier to do. But you might also need to place them in a couple more intricate and difficult locations to ensure that the entirety of the design is held in place during machining. So I've placed a couple tabs here across my design, and then I'm going to click calculate. Now you notice that that will calculate your toolpath. You can see that the toolpath is placed quite a bit away from the design here because of my offset, And you can also see that there are some triangular shaped tabs along the perimeter of my design. So let's close that. And then let's click on our base part perimeter and make another 2D contour toolpath. And for the most part, we can keep the same settings. So end depth will be 21 millimeters, using our single flute 25 millimeter end mill there, running along the outside, but this time I won't put an offset, so I'll set my offset to be 0. We don't need ramping, and we do need some tabs. So let's click the add button and add maybe 4 tabs along this base part here before calculating our toolpath. And now you can see that the toolpath runs much closer. Now you'll notice that there's a gap, of course, right? So there is a gap. So you might be thinking, I thought the offset was set to be 0. But the gap that you're seeing is because the cutting tool is centered along this white toolpath line. So the cutting tool of 3.175 millimeters will be centered along this line, which means half of the cutting tool will be coming right along my base part here. All right, so I'm going to close this. After generating all the toolpaths for the bottom of the project, we can export them as a G-code file for manufacturing as we did earlier for the top of the design. But before we begin to manufacture the design, we must load our stock. Our piece of wood can be loaded onto a piece of wasteboard placed onto the bed of our Carvera Air and ensure that this wasteboard is thick enough to compensate for the pinholes we will be drilling that will be used to flip our stock later on. We can then use a combination of corner clamps and top clamps as shown. With thicker stock like this, you might want to use risers or washers to allow you to better grab onto your stock, or consider using a different type of clamp like side clamps to grab the edge of the stock instead. Then in the Makera controller app, we can upload our exported G-code files and prepare them for manufacturing after we've connected to our machine. I'll upload both the top and bottom file at the same time, but of course we'll be working with just the top file as we begin to manufacture this project. So with the top file selected, we can preview our design. We can also preview the G-code, and then we can head over to the Run and Configure window to configure this project for manufacturing. If you'd like, you can adjust your work origin offsets. However, these offsets must be proportional and match both the top and bottom in order to ensure that the flip is successful. So we would always recommend that you set your work origin offset to 0, 0 from your anchor position and instead make any offsets manually in the CAM file, as discussed earlier when we were repositioning the design files in Makera CAM. Scan margin can be enabled, and that will trace the perimeter of your design on your stock to ensure it's going to be machined in the correct location. And we can use auto Z probe or auto leveling to check the height of our stock and compensate for any deviations automatically. For something like this, I'm not actually going to use auto leveling, but I will use auto Z probe and set the probing point to be in the center of my stock, which would be at a work origin of 75 by 75 based on my stock size. So that'll probe right in the middle of my stock, which is helpful when you're doing a flip and machining through the surface of your part. Once set, we can click Run to begin to manufacture the top of our design. After completing the scan margin and Z probing sequence, the Carvera Air will prompt us to load the first tool, while the Carvera will select this tool automatically. After loading tool 1, the 0.5 millimeter engraving bit into the Carvera Air using the quick tool changer, we can press the button on the top of the machine to continue. The engraving bit will machine the detail in the Rabbit design before the Carvera Air prompts us for a tool change. It will then complete the drilling operation using our alignment holes with the end mill that we've selected, followed by a pocket clearing operation for the base part using either the same bit or a different bit depending on how you set up your CAM profiles. Once the top of the project is completed, we can unclamp it and remove it from the machine without removing the wasteboard that we drilled into. We can then insert alignment pins into the holes that we drilled into the wasteboard, flip our stock horizontally as we did in our CAM program earlier, and align it to the pins rather than the corner clamp. After aligning it, we can use clamps to secure the stock before continuing to manufacture. Back in the controller app, we can now select the bottom design file and open up the Run and Configure window. Here we want to make sure that we don't adjust the work origins to keep our design aligned and proportional. We can choose to adjust scan margin and auto Z probe, and we can choose to use auto leveling if desired, but for this, I'll use scan margin and probing the center of my stock just like I did for the first side. Once everything's set, I can click Run to manufacture this project. After the probing sequence, we can load the engraving bit to machine the detail pocket of our design for the rabbit on the bottom side now, before loading the single flute end mill to cut out each part using a contour toolpath. The Carvera Air will work through the stock by cutting along the perimeter of our designs, but not through the tabs that we created so that the part will remain in place. Once finished, we can remove the part and safely cut it and sand the tabs, and that's all there is to it. This type of project takes advantage of the Carvera and Carvera Air's ability to easily set up your CNC projects through Makera CAM for something as simple as two-sided machining projects like this one. Check out our other tutorials for our spring-themed project examples on the Makera channel, and of course, please don't forget to subscribe.